The Big Bang is often depicted as a massive explosion, but that image is misleading. Instead of an explosion in space, imagine space itself expanding. Picture a tiny, incredibly dense point containing all the matter and energy in the universe. About 13.8 billion years ago, this point began to rapidly expand. This expansion continues to this day. The Big Bang wasn't an event that happened in a pre-existing space. It was the beginning of space and time as we know them. It's hard to wrap our minds around, but the universe wasn't born into existence. Rather, existence itself was born with the Big Bang. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move farther apart. Similarly, the expansion of the universe causes galaxies to move away from each other. The farther away a galaxy is, the faster it appears to be receding from us. This expansion doesn't mean we're at the center of the universe. Think of it like baking raisin bread. As the bread rises, every raisin sees all the other raisins moving away from it. In the same way, every point in the universe appears to be the center of the expansion. How do we know the Big Bang happened if no one was around to see it? The answer lies in the cosmic clues left behind, like whispers from the early universe. One such clue is the cosmic microwave background radiation, often called the CMB. Think of the CMB as the faint afterglow of the Big Bang. It's a faint microwave signal that permeates all of space. This radiation was released when the universe was very young, about 380,000 years after the Big Bang. Another crucial piece of evidence is the abundance of light elements like hydrogen and helium in the universe. The Big Bang theory predicts the precise ratios of these elements that should have been created in the early universe. Astonishingly, these predictions match the observed abundances remarkably well. The expansion of the universe, the presence of the CMB, and the abundance of light elements all point towards the Big Bang. These are not mere coincidences, but rather powerful pieces of evidence that support the Big Bang theory. The very first moments after the Big Bang were a time of unimaginable heat and density. Our current understanding of physics struggles to describe this period accurately. We call it the Planck epoch, a time when the universe was less than a trillionth of a trillionth of a trillionth of a second old. As the universe expanded and cooled, it went through a period of rapid expansion called inflation. Imagine a universe smaller than an atom suddenly inflating to the size of a grapefruit in a fraction of a second. This rapid expansion helps explain why the universe appears so uniform on a large scale. As the universe continued to cool, energy began to condense into matter and antimatter, which annihilated each other upon contact. However, a slight imbalance, about one extra matter particle for every billion pairs, allowed matter to win out. This tiny surplus is what makes up all the stars, planets, and you and me today. Protons and neutrons, the building blocks of atoms, began to form. Over time, these particles would come together to form the first atoms, primarily hydrogen and helium. This process, known as Big Bang nucleosynthesis, laid the foundation for the formation of stars and galaxies. The Big Bang theory is often misunderstood. One common misconception is that it was an explosion in empty space. Remember, there was no space or time before the Big Bang. The Big Bang wasn't an explosion space, it was the expansion space itself. Another misconception is that the Big Bang explains the origin of the universe. While the Big Bang theory describes the early evolution of the universe, it doesn't explain what caused the Big Bang or what, if anything, existed before it. The question of what came before the Big Bang is a bit like asking what's south of the South Pole. Our current understanding of physics breaks down at the singularity of the Big Bang, making it difficult to even formulate such a question. While we may never know for sure what, if anything, came before the Big Bang, scientists continue to explore various ideas, including the possibility of a multiverse or a cyclical universe. The Big Bang theory is a remarkable achievement in science, but it's not the final word. Many mysteries about the universe remain, and scientists are constantly striving to uncover the answers. One of the biggest puzzles is the nature of dark matter and dark energy. These invisible entities make up the vast majority of the universe's mass and energy but don't interact with light, making them difficult to study. Another mystery is the origin of the universe's structure. How did the smooth, uniform soup of the early universe evolve into the intricate web of galaxies and galaxy clusters we see today? Fortunately, we live in an exciting time for cosmology. New telescopes and observatories are coming online, providing us with unprecedented views of the universe. These instruments are helping us probe the mysteries of the Big Bang and refine our understanding of the cosmos. The Big Bang wasn't just an event in the distant past. It's the reason we are here. The atoms in our bodies, the earth beneath our feet, and the stars in the night sky were all forged in the fiery crucible of the Big Bang. By studying the universe, we're uncovering the story of our own cosmic origins. Please don't forget to subscribe, like and share with your friends. Thanks for watching.